right, hello. We are doing chapter 4, section 3, and this is an intro to derivatives. And so these are probably something you haven't ever seen or done or utilized in the past. And so I'm going to do a little bit of talking and explaining what a derivative is, and then we'll talk about mathematically what they are. So first, this is where mathematically we put our exponents to use. Okay. Secondly, in the real world, we don't do a whole lot of real world math in math class. And the reason is it doesn't really come into play until you have a very upper level understanding of math, like calculus. So this is actually in a calc class. And so we can kind of start to talk about that. So in the real world, derivatives are used to calculate how fast something is changing. So an example is if a business, let's see, has profit changes over time, the derivative tells you how quickly or conversely, how slowly that profit is increasing or decreasing. Okay. Another example, and we're actually going to utilize this in this chapter, is on a graph, the derivative tells you the steepness, which is also the slope of the curve. Oops, that should be a U. Sorry. Of the curve. Or it can help you find a line that is tangent. That means something totally different than in trigonometry. Tangent means it's touching. That is tangent to the curve. Okay, so specifically what that means is that it touches the curve at a specific point and it has the same slope as the curve at that exact point. That's the word point, by the way, kind of mixed together. And we're going to be doing this later in the chapter, so it's just nice to kind of explain that. So, all right, let's go to the next screen and we'll talk about mathematically what is happening. Okay, so mathematically, here is how you find a derivative. And I'm not going to give you some generic formula. I'm just going to do a couple examples and explain what's happening. So if f of x is 6x to the third, and that's it. We're just going to deal with a monomial here. Excuse me. Then f prime of x, this is how you notate the derivative, is equal to 18x. And let me tell you exactly what's happening here. So this 3, the exponent, is coming down and getting multiplied. So you multiply an exponent by the coefficient for that term. Okay, that's where, so in this case, in this example, you're multiplying 3 times 6. Okay, you keep your variable in this case, and then, and I haven't done this yet, subtract 1 from the exponent to get a new exponent term, exponent value, I guess. So in this case, the 3 would be a 3 minus 1. This would equal a 2. And that 2 goes right here. And f prime of x would equal 18x squared. Okay, so you're literally multiplying these two together. These two guys multiply. Take 1 off the value here and put a new one on there, new exponent on. Okay, so let's see what this one is. If f of x is equal to 3x squared minus 4x plus 1, then f prime of x is going to equal, so I'm going to bring this guy times this guy, so that's going to be a 6, 2 times 3, right? So I'm going to go 2 times 3. That's going to give me a 6, x, and then I'm going to go 2 minus 1, so, and that's a 1, so this is just going to be x to the first, which you don't need that. And then this one has a 1, so I would go 4 times 1, which is 4, minus 4. And then I would go 1 minus 1, and that's a 0. Well, x to the 0 means there's no x. So this would not have an x value on it. So this is equal to 6x minus 4. Okay. All right. Let's do another one, a big giant one. Okay. If, oops, wrong tool. If f of x is 5x to the fourth minus 3x cubed minus 7x squared plus 12x plus 13, find f prime of x. Now, why don't you pause your screen here And you find one, what you think f prime is, and then when you're ready, come back and see what the answer actually is here. Okay, so here's what we're going to get. If you pause, we're going to multiply these guys together. So that's going to be 20x, and I'm going to drop a power off the 4 and get a 3. And then I'm going to multiply the 3 and the 3 to get a 9x, drop a power off, and a squared. Multiply the 7 and the 2, so minus 14x, no power on that guy. And then this one would be plus 12. And this guy does not factor into our derivative at all. In fact, this is actually an important note. The derivative of a constant equals 0. So if you're asked to find if f of x equals 1016, find f prime of x, well, that's going to equal 0. And I'll tell you why, because technically what this is 1016, and it has an x to the 0. And what is anything to the 0 power? Well, that's 1, right? So this is really 1016 times 1. So x to the 0, if you bring that 0 down and you multiply it by the 1016, you get 0. That's what's actually happening here mathematically. So if you just remember, though, that any constant, if it doesn't have an x on it, the answer is 0. So here, f prime of x equals 0. Okay? I believe there's a problem like that on the varsity assignment that you're going to be doing. Okay, so now that we have the basic idea of how to take a derivative, let's look at a couple of tricky things and things that I need you to remember. Excuse me. Let me see how many slides I have left. Okay, a couple. Okay, so here's something that I need you to remember. Exponent rules. So remember that a to the minus m is equal to 1 over a to the m, right? And a to the m over n is equal to the nth root of a, that's a square root, where the n is the index, to the m. These are going to come in handy, and you're going to need them a bunch, okay? And here's an example of that. So here's your first one. Find the derivative of 6 square root of t. Okay, that's the problem. So first, I want you to recall that the root of t is equal to t to the 1/2, right? So we need that exponent power in order to do anything. So if f of x is 6t to the 1/2, then when I do f prime of x, I'm going to bring that power down and multiply it times 6. And then I'm going to take the power and subtract off 1. Well, 1 is really 2 over 2, right? So that's 1. So this is going to give me 1/2 times 6. That's 3. T, 1/2 minus 2/2 is a negative 1/2. Well, remember that you can't leave an exponent negative. So you have two options here. Using this rule up here, a to the minus m, this would be the 3 would stay on the top. 3 over t to the 1/2. You could answer that this way, or you could put 3 over the square root of t. Both of these would be acceptable answers in varsity. Okay? You're definitely going to see something like that, and you need to get comfortable dealing with these fractional exponents. Okay? Here's the next one. given f of x is equal to, I don't know why we're having this delay here, 5x to the 3 halves. Find f prime of 4. Well, remember that means you're going to plug 4 in for any x, right? So the first thing we have to do is find f prime. So f prime of x is going to be, bring the power down. We're going to multiply that by the coefficient. We're going to subtract 1 off the power. Yeah, maybe it would be smarter to write this as 2 halves. Okay, so this goes to 15 halves. Remember, this would go over 1 and you just multiply straight across. Okay. And then 3 halves minus 2 halves is 1 half. So x to the 1 half. Okay. So now I have to find f prime of 4. Okay, so I'm going to plug 4 in for the x. So I have 15 halves. Let me change my color again. 15 halves times 4 to the 1 half power. Well, remember 4 to the 1 half power, I'm going to go up here. 4 to the 1 half is equal to the square root of 4, and the square root of 4 equals 2. So this is now 15 halves times 2 or 1. These guys would cancel, and I'm left with 15. Okay? So there's 2 examples of how we're going to use derivatives and the rules of exponents that we've already learned to do these things. Okay, there are 2 more examples here. Let me do one more on this page, and then I'm going to go from there and do the rest. So I'm going to go given, this is weird that is pausing like that, f of x equals 1 over x to the 3rd. We're going to find f prime of 2. Okay, so the first thing we're going to do here is find f prime of x, and then we're going to sub in 2 for x, negative 2 actually. Okay, so let's do this first. If we go f prime of x is equal to, this is really x to the minus 3, right? You've got to start thinking of those. If they're in the denominator, it's a negative exponent. So I'm going to rewrite this as negative 3x to the minus 4. And be careful here, because this is really negative 3 minus a 1. So now I'm going to take this and go negative 3 over x to the 4th. And then I'm going to sub in that negative 2. So I've got now negative 3 times negative 2 to the 4th. Negative 2 to the 4th is equal to 16. So this equals negative 3 over 16. Okay, one more example, and then we're all done with this section. All right, so on to the next screen. The last one looks like given f of x equals 4x to the 3rd minus 3x squared, find where f prime of x equals 0. Okay, well, think about what that's actually asking. If we have to find where f prime of x equals 0, the first thing we have to do is find f prime of x. So let's do that. That's an easy thing to do. So we know the exponent's going to come down. This is going to be a 12x squared minus 6x. Okay, there's our derivative. Now, what's the derivative set equal to 0? So we're just going to get rid of this and say my derivative equals 0. And now you're going to solve for x. Okay, so when I solve for x, I'm going to factor out a common factor. So 6x times 2x minus 1 equals 0. And anytime you're solving, you're going to set each factor equal to 0. And solve. So we have 6x equals 0, which means you divide by 6 and divide by 6, and you get x equals 0. And then we have the binomial, 2x minus 1 equals 0. Move the 1, so you get 2x equals 1. Divide by 2, and you get x equals 1/2. Now, in the case where you get two answers like this, just write them in the answer spot for varsity with a comma in between them. Okay, so that is your 4.3 notes, intro to derivatives. We will be doing a bunch of things with them moving forward. All right, let me find out how to turn this video off. Might take me a second.